Ocean waves, radio waves, light waves, as well as microwaves are all modeled using the trigonometric functions sine and cosine. Yes, surfers who use technology to predict where the good surf is going to be use trig to help them track the best surf. Hi, my name is Jason Rosenberry, and that is what we will be examining in today's lesson, trig functions and their graphs. Let's start by reviewing the graphs of the 6 trig functions. So on the left side we have y equals sine x, the most basic sine graph that we can produce. The domain of this function is all real numbers, negative infinity to positive infinity. The range of this graph, notice that the y values go no lower than negative 1, no higher than positive 1, so the range is negative 1 to positive 1 inclusive. And the period of this graph is 2 pi, meaning that it takes 2 pi radians for the graph to complete a full cycle. So if we were to trace the graph from 0, 0 and go through all of the range values and back to 0, 0, we can see that it takes 2 pi radians for that to happen. On the right hand side we have y equals cosine x. Domain again is all real numbers. Range again is from negative 1 to 1 inclusive, and the period is 2 pi. Here we have the graphs of the tangent and cotangent x functions. On the left we have y equals tangent x. The domain is the set of all x such that x cannot be any odd multiple of pi over 2. The range spans from negative infinity to positive infinity, or all real numbers, and the period is pi. Notice we have vertical asymptotes occurring for all of those values that are not in the domain. On the right hand side we have the cotangent x function. Here the domain is the set of all x such that x cannot be 0 nor any multiple of pi. The range is all real numbers, and again the period is pi. Here we have the secant and cosecant functions. On the left, y equals secant x. The domain is the set of all x such that x cannot be any odd multiple of pi over 2. The range value must either be less than or equal to negative 1 or greater than or equal to positive 1. Period's 2 pi. Cosecant x, the domain set of all x such that x cannot be 0 nor any multiple of pi. Again, the range is the same as secant x. Values must be less than or equal to 1 or greater than or equal to positive 1, and period again is 2 pi. So for sine, cosine, secant, cosecant, the period is 2 pi, and for tangent, cotangent, the period is pi. Because the trig functions repeat at regular intervals, we say they are periodic. In general, a periodic function is defined as follows. A function f of x is periodic if there is a positive number p such that f of x plus p equals f of x for every value of x. The smallest such value of p is called the period of f. Again, note that the sine, cosine, secant, and cosecant all have period 2 pi. The tangent and cotangent have period of pi. Let's move on and review the rules for transforming the graph of a function. Here we have the general form for any function out there. Y equals a times f of b times x plus c plus d. Notice that the a value tells us information about a vertical stretch or shrink. Also tells us information about being reflected about the x-axis. The b value, horizontal stretch or shrink, reflection about the y-axis. C value, horizontal shift. D value, some type of vertical shift. Now we take all of these ideas and apply them to a general sine function, or a sinusoid form. General sine function or a sinusoid form. F of x equals a sine of 2 pi over b times x minus c plus d. What this tells us is the absolute value of the a value is the amplitude of this sine function. The absolute value of b is the period, c is the horizontal shift, and d is the vertical shift. Let's try an example. Temperatures in Fairbanks, Alaska. Find the amplitude, period, horizontal shift, and vertical shift of the model f of x equals 37 times sine of 2 pi over 365 times the quantity x minus 101 plus 25. Let's start with the amplitude. Here our a value is positive 37. The absolute value of that is 37. So the amplitude is 37. The period is equal to b. Here the absolute value of 365 is 365, so the period is 365. Horizontal shift, we want to take a look at the c value. Here c is negative 101. Therefore the horizontal shift would be 101 units to the right. And here positive 25 as our d positions our vertical shift value, so the vertical shift would be 25 units upward. Let's move on to the inverse trig functions. Here are their definitions.
The inverse cosine function has a domain of -1 to +1 inclusive and a range from 0 to pi inclusive. The inverse sine function has a domain of -1 to +1 inclusive and a range of -pi/2 to +pi/2 inclusive. The inverse tangent function has a domain from -infinity to +infinity and a range from -pi/2 to +pi/2. The inverse secant function has a domain such that the absolute value of x must be greater than or equal to 1. The range is from 0 to pi inclusive. Y cannot equal pi/2. The inverse cosecant function has a domain such that the absolute value of x is greater than or equal to 1 and has a range from -pi/2 to +pi/2 inclusive. Y cannot equal 0. And the inverse cotangent function has a domain from -infinity to +infinity and a range from 0 to pi.
Solve for x. Here we have tangent x equals -2, and we want to look for values in the interval -infinity to +infinity. So we want to find all values of x that satisfy tangent x equals -2. So use the calculator to find the angle whose tangent is -2. And when using the calculator and the inverse tangent function of your calculator, you'll see that that value is -1.107, which is in the fourth quadrant. We also need to remember that the period for the tangent function is pi. So there's an infinite number of solutions, and we can write them such that x is equal to -1.107 plus pi times k, where k is really any integer. So we could have k is equal to 0, plus or minus 1, plus or minus 2, etc. Now it's time for you to try a problem. Evaluate the expression, find the sine of the inverse cosine of 7/11. Pause the video while you work on this problem. When you are finished, restart the video to check your solution. So we first want to start with the inverse cosine 7/11. That is the angle that we want to identify. Inverse cosine will either be quadrants 1 or 2, and since 7/11 is positive, we're working with a quadrant 1 angle. So imagine this quadrant 1 angle, theta, whose cosine is 7/11. So it tells us that the x value is 7 and the r value, or the radius of the circle or the hypotenuse of this triangle, is 11. Using Pythagorean theorem to find the missing side, 7 squared plus something squared gives us 11 squared, and that is equal to 6 root 2. So the missing side again by using Pythagorean theorem is 6 root 2. And now we want to turn around and find the sine of that angle. So the sine of that angle would be y over r. So that answer would be 6 root 2 all over 11. In this lesson, we explored the trigonometric functions, their graphs, and their inverses. Be sure to work the exercises that your teacher assigns, and we'll see you next time.